What if I told you there's a hidden force in the Pacific Ocean? One that can drown entire cities, ignite wildfires on the other side of the planet, crash economies, and even starve entire ecosystems? This force has a name: El Nino, and it's already on its way, quietly building power beneath the waves, ready to reshape the planet again. The question is, are we prepared? For centuries, fishermen along the coast of Peru and Ecuador noticed something strange. Around Christmas time, every few years, the waters would suddenly warm, fish would vanish, storms would arrive, crops would fail. They named this mysterious force El Niño de la Navidad, the boy child of Christmas. At the time, they didn't know they were witnessing the surface ripples of a planet-wide climate engine, an invisible hand reaching across oceans, bending weather patterns, and flipping ecosystems upside down. Today, we call it ENSO, the El Niño Southern Oscillation, and it's one of the most powerful climate cycles on Earth. It can trigger mega-droughts in India, unleash torrential floods in South America, and disrupt jet streams that steer hurricanes toward North America. Sometimes it lasts just a few months, other times it lingers for years. And here's the kicker: it doesn't just affect coastlines or the tropics. El Niño will affect you, your food prices, your local weather, maybe even your safety. But what exactly is it? How does this pattern rise and fall with such destructive rhythm? And is 2023 the year we face another global shift? We'll unravel the mystery of El Niño, its science, history, and its impact on the entire planet. We'll explore the unseen forces deep beneath the ocean's surface, meet its counterpart La Niña, and look at what the future may hold, not just for Earth, but for any world where we dream of building life. Because understanding Earth's climate cycles is not just about surviving today. It's about preparing for tomorrow, anywhere. To understand what El Niño really is, we first need to understand what normal looks like. Imagine you're standing on the Pacific coastline, watching the ocean stretch thousands of kilometers westward, all the way to Southeast Asia. On most days, invisible forces are already at work. Trade winds, born from the rotation of our planet, blow steadily from east to west across the equator. These aren't gentle breezes. They're persistent planetary winds, part of a vast atmospheric engine shaped by something called the Coriolis effect. Here's how it works. As the Earth spins, air moving from high-pressure areas near the poles gets deflected as it approaches the equator. In the tropics, this creates strong bands of wind that wrap around the globe. These are the trade winds. They're the same winds that once carried sailing ships across oceans, but today they play a much deeper role in shaping our planet's climate. As these winds push surface water westward, warm water piles up in the western Pacific, near places like Indonesia and Papua New Guinea, forming a deep pool of heated ocean. This creates a pressure difference across the ocean, with cooler, nutrient-rich waters rising up to replace the displaced warm water near the Americas. This process is called upwelling, and it's the lifeblood of the Pacific's marine ecosystems. Cold water surging from the ocean depths carries it with nutrients, phosphates and nitrates, that feed microscopic phytoplankton. These in turn feed fish, whales, seabirds, and entire food chains. So under normal conditions, the Pacific Ocean is an immense conveyor belt. Warm water flowing west, cold water rising in the east, and the winds above pushing steadily along the equator. It's balanced, it's stable, it's predictable. And when it works, the Pacific acts like a giant climate moderator, keeping ecosystems, agriculture, and weather patterns in check across multiple continents. But what happens when this delicate rhythm is interrupted? What happens when the winds slow, or even reverse. That's when the Pacific begins to breathe differently. That's when El Niño arrives. Something subtle begins to change. The reliable trade winds that have blown for months across the Pacific start to weaken just a little at first. But in the delicate system of Earth's climate, a little is enough. As the winds slow, their grip on the ocean relaxes. That pool of warm water, normally pushed west toward Asia, stalls. Then it begins to shift eastward, creeping back toward the Americas. The balance breaks. El Niño has begun. With less force driving warm water west, the usual upwelling of cold, nutrient-rich water along the coast of South America falters. In some regions, it stops entirely. Without the cold water rising from the deep, entire ecosystems begin to suffocate. Phytoplankton die off. Fish migrate or vanish. Birds starve. And coral reefs, already on the edge, begin to bleach. But the damage doesn't stop at the sea. That massive pool of warm water now sitting off the Americas acts like a giant atmospheric battery, releasing intense heat into the air above it. This energy shifts the position of the Pacific jet stream, a high-altitude current of air that influences weather over entire continents. The jet stream is nudged off course, and like a river flowing into new territory, it takes the weather with it. In North America, the northern states often turn drier and warmer, while the southern U.S. and Gulf Coast become wetter, sometimes disastrously so. California may see record rains and flooding. But South America faces even greater extremes. In Peru and Ecuador, rainfall surges beyond control. In the devastating El Niño of 1997 to 1998, entire towns were swallowed by mudslides. The normally dry Tumbles region received 16 times its average annual rainfall. Over 250,000 people were displaced, and vital infrastructure was destroyed in days. And while some regions drown, others burn. India's monsoon can fail. Australia can ignite. During strong El Niño years, bushfires rage through Australia's outback, fueled by heat, dryness, and parched vegetation. The Earth's climate enters a state of disarray, reacting to a signal from the sea. And here's the thing: El Niño doesn't follow a script. Some events last 9 months, others more than 2 years. Some are mild, others are devastating, and each one is unique, shaped by other shifting forces in Earth's atmosphere and oceans. But no matter the scale, the fingerprint is always the same. The Pacific pulses, and the world trembles. And as we'll soon discover, the story doesn't end there. Because when the ocean swings in the other direction, when the trade winds return fiercer than ever, a new force emerges, a cooling counterpart with power just as unpredictable. Next, La Niña awakens. The Pacific may be the heart of El Niño, but its pulse is felt across the entire Earth. What starts as a shift in ocean temperatures quickly cascades through atmospheric currents, rainfall patterns, and global weather systems. In some places, it brings floods. In others, fire. And the line between the two is often terrifyingly thin. Let's begin with South America, where El Niño was first observed. During strong events, countries like Peru, Ecuador, and Colombia face punishing rains. Roads become rivers. Villages are buried in mud. In 1998, one of the strongest El Niño years on record, rural communities were erased, bridges collapsed, and drinking water became a luxury. But while one continent drowns, another begins to crack under drought. In South Asia, the monsoon rains that normally sustain billions may never come. India has experienced multiple failed harvests during El Niño years, leading to food shortages and spikes in commodity prices that ripple across the globe. Meanwhile, in Australia, the combination of heat, drought, and wind becomes a deadly trifecta. El Niño years have historically aligned with some of Australia's most catastrophic bushfires. The 1982-83 Ash Wednesday fires killed 75 people. The Black Summer of 2019-2020, though not a classic El Niño year, was amplified by related conditions, scorching 50 million acres and releasing more carbon into the atmosphere than 100 nations combined. In Africa, the effects are equally split. The Horn of Africa often faces drought, while southern regions like Zimbabwe and Mozambique may see excessive rains and flash floods. And then there's the ocean itself. Warm waters from El Niño disrupt the entire Pacific marine food chain. Coral reefs bleach and die, removing safe habitats for thousands of species. In 1998, 16% of the world's coral reefs were wiped out due to El Niño-triggered heat waves. Some scientists still consider it a global ecological tipping point. And while these patterns sound distant, their effects reach your doorstep. In the United States, the Pacific jet stream shifts south, rerouting storms across Texas, Louisiana, and Florida. The northern states, meanwhile, may see a mild winter, which sounds nice, until you realize it means less snowpack, less water in reservoirs, and higher wildfire risk later in the year. Globally, the planet's average surface temperature rises about 0.1 degrees Celsius during an El Niño. That may seem small, but in a world already warming, it's like pouring gasoline on a fire. And yet, no two El Niño events are alike. Some, like 1982-83 or 1997-98, became infamous. Others pass more quietly, reminders that this system is chaotic, dynamic, and not fully understood. But there's one certainty. El Niño is never just a local phenomenon. It's a planetary whisper that can turn into a scream. So what happens when this powerful pattern swings in the opposite direction? What does the cool sister of El Niño bring with her? Let's find out in the chilling wake of La Niña. If El Niño is the ocean's fever, then La Niña is its deep, chilling breath. Where El Niño disrupts by heating the Pacific, La Niña intensifies the system's normal mechanics, but with amplified effects. And just like her warm sibling, she too leaves chaos in her wake, only of a different flavor. Let's go back to the trade winds. During La Niña, these winds don't weaken, they strengthen. They whip even more warm surface water away from South America toward the Western Pacific. And that creates a powerful vacuum, pulling up deeper, colder, nutrient-rich waters in a process called enhanced upwelling. It's a buffet for the marine ecosystem. Anchovies swarm, plankton bloom, and fisheries thrive along the coast of Peru and Ecuador. In fact, during strong La Niña years, these fisheries can see record hauls. If you enjoy salmon or calamari, La Niña may have helped put it on your plate. But as we know by now, nature rarely gives without taking. Across the Pacific in Southeast Asia, the extra heat and moisture lead to stronger monsoons and tropical cyclones. Flooding in places like Bangladesh, Indonesia, and the Philippines can become disastrous, drowning farmland, displacing families, and fueling landslides. In Australia, paradoxically, La Niña can bring too much water. While El Niño scorches the land, La Niña drowns it. Towns flood, dams overflow, entire road systems vanish beneath murky torrents. In 2010 to 2011, a La Niña event led to one of the costliest natural disasters in Australian history. In the United States, the effects flip again. the Pacific Northwest gets drenched, rainfall spikes, and snowpack deepens. But California and the Southwest, they dry out, and not just a little. La Niña has been linked to historic mega droughts, including the one that's now threatening Lake Mead and the Hoover Dam, a crisis scientists say may be the worst in 1,200 years. And just like El Niño, La Niña has a signature in the sky. In Africa, rainfall patterns invert. The Horn of Africa, including Ethiopia and Kenya, often suffers brutal drought. Yet southern Africa, from Mozambique to Namibia, experiences intense flooding, reversing the extremes of the previous cycle. And while the Pacific Basin sees fewer hurricanes during La Niña, the Atlantic Basin becomes a breeding ground. La Niña conditions reduce vertical wind shear in the Atlantic, allowing more hurricanes to form and intensify. In fact, many of the most active and destructive hurricane seasons in modern history, like 2005's Katrina or 2020's record-breaking season, occurred during La Niña phases. So here's the twist. El Niño and La Niña are opposites, yes, but not perfectly balanced. Their impacts are asymmetrical, their triggers complex, and each one sets off unpredictable chains of cause and effect depending on geography, season, and timing. That unpredictability brings us to a critical question. Where are we right now in the cycle? And what does the data say about what's coming next? Let's dive into that in the next chapter, Current Status and Forecasts. To understand what El Niño or La Niña will do next, we need to look at the data. Right now, as of this video's release, we're standing at a crossroads. The most recent readings from NOAA, the U.S. National Oceanic and Atmospheric Administration, confirm something big. La Niña has just ended, and now the Pacific is entering neutral territory. But what happens next could reshape the climate of 2024. Let's talk about how scientists actually measure this. One of the key indicators is the Equatorial Southern Oscillation Index, or EQSOI. This tracks the difference in air pressure between 2 points across the Pacific, Tahiti and Darwin, Australia. When the pressure difference is high, La Niña is likely dominating. When it's low or reversed, it signals the arrival of El Niño. Right now, that index has dropped close to 0.1, a neutral reading. And here's where it gets interesting. According to NOAA and multiple international climate centers, there's a 60 to 70% chance that El Niño will develop in the coming months, possibly by autumn. That may not sound dramatic, but in climate science, that's a loud alarm bell. Because if El Niño takes hold, we could see a sharp spike in global temperatures, and potentially a record-breaking year for weather extremes. Let's zoom out for a second. Since modern tracking began in the 1950s, Earth has never gone more than 4 consecutive years without an El Niño event. The last one occurred back in 2019. So if we don't see an El Niño soon, it would break a 70-year pattern. But odds say otherwise. Early sea surface temperature readings already show unusual warming in the eastern Pacific, and meteorologists have begun preparing nations for droughts, floods, and wildfires, depending on how severe the event becomes. India has issued early warnings of possible monsoon disruption. Agricultural experts are preparing for shifts in crop yields, and energy markets are bracing for hydropower volatility and heating demand. So what does this mean for you? Even if you don't live near the Pacific, even if you're not watching the jet streams or fishing for anchovies, the price of food, the intensity of your summer, and the timing of your next storm might be about to change. all because of a silent shift in wind and water thousands of miles away. And yet, there's something even bigger to consider. If we can predict El Niño, can we learn to control climate systems on Earth and one day on other worlds? What El Niño and La Niña reveal isn't just about rain, heat, or ocean currents. It's about something far deeper: the hidden machinery of Earth's climate. ENSO, the El Niño Southern Oscillation, isn't just a periodic disturbance. It's a glimpse into the massive interconnected systems that govern our world. Systems so vast that a change in wind direction over the Pacific can trigger wildfires in Australia, droughts in India, and floods in Peru, all within the same year. And yet, through satellites, sea buoys, and atmospheric sensors, we're beginning to decode it, to anticipate it, to adapt to it. But here's the big question. If we can learn to understand these climate patterns here on Earth, could we eventually predict, maybe even engineer, climates on other planets? When we dream of terraforming Mars, building habitats on the Moon, or one day living on exoplanets light years away, we'll face a new challenge. No climate, no jet stream, no rainfall, no ocean currents to moderate life, unless we create them. And to do that, we must first master the feedback loops of our own planet. ENSO is one of the most powerful examples of a climate feedback system we have. It teaches us how energy, water, and atmosphere dance together across time and space. So maybe, in studying the extremes of El Niño and La Niña, we're not just forecasting storms. Maybe we're practicing something much larger: the science of planetary survival. But now, I want to hear from you. Have you ever felt the impact of El Niño or La Niña where you live? A heat wave that came early? Rain that wouldn't stop? A winter that just didn't feel right? Let me know in the comments. I'd love to hear your story. And if your mind's still spinning with what you just learned, wait until you see what's coming next. Click over to my next video. It'll challenge everything you thought you knew about space, time, and the limits of life on Earth. Stay curious, stay alert, and as always, thank you for watching.